Today topic is hidden station problem. So in hidden station problem, we are going for a Bluetooth concept. Before that, we have to know what is meant by hidden station problem. So already we have seen 802.11 MAC sublayer protocol. So in hidden station problem, it is quite different from the Ethernet due to the inherent complexity of the wireless environment compared to that of a wired system. So in Ethernet, we can have a station just wait until the Ethernet goes silent and start transmitting. If it does not receive a noise burst back within the first 64 byte, the frame has almost assuredly been delivered correctly. So within wireless, this situation does not hold. So we are having a hidden station problem and an exposed station problem. A wants to send to B but cannot hear that B is busy, and then B wants to send to C but mistakenly thinks that the transmission will fail. So in hidden station problem, we are going for to start with the hidden station, since not all station are within the radio range of each other. Transmissions going on in one part of a cell may not be received elsewhere in the same cell. So station C is transmitting to the station B. If A senses the channel, it will not hear anything and falsely conclude that may not now start transmitting to B. So there is a inverse problem, the exposed station problem. That is, here B wants to send to C, so it listens to the channel. When it hears a transmission, it falsely concludes that it may not send to C, even though A may be transmitting to D. So most radios are half duplex, meaning that they cannot transmit and listen for noise burst at the same time on a single frequency. As a result of this problem, we are going to A02.11 does not use CSMA CD as Ethernet does. So, and then we are using a handshaking for a hidden station problem. We are going to send a RTS to the station A, and then we are going to send the CTS as well as to station A and C. This is a exposed station problem diagram. So I already explained that what is meant by exposed station problem. So in this A B wants to send to C, so it listens to the channel. When it hears a transmission, it falsely concludes that it may not send to C, even though A may be transmitting to D, that is not shown here. So most radios are off duplex. So it means that they cannot transmit and listen for noise or a noise burst at the same time. So this is the diagram for exposed station problem. So we are having a B to A to C, we are having a RTS, and then we are going to send the data to by using a RTS to the C and D also. So in this place we are going to occurring some collisions. So since station C hears the RTS from A but does not hear the CTS from B. So station C, after hearing RTS from A, it can wait for a time so that the CTS from B reaches A. It then sends the RTS to D, show that it needs to communicate with D. Both the stations B and A may hear this RTS, but station A is in the sending state, not the receiving state. So this is the IEEE 802.11 physical layers we are going to use. One is FHSS and DSSS, and then OFDM, and then DSSS and DSSS 11G. So this is the technique and what are the band we are going to use here, and then what are the modulation we are going to applying, and what is the rate of Mbps. In 802.11 we are using a FHSS and DSSS. So band we are going to use for 2.4 GHz and infrared, and then modulation is FSK, PSK and PPM, and then rate of Mbps is 1 and 2. And 802.11a we are going for OFDM, and then 5.725 GHz PSK or QAM 6 to 54 Mbps, and then we are going for 11G OFDM technique is used 2.4 gigahertz and different 22 and 54 of rate Mbps. So this is a physical layer of IEEE 802.11 FHSS. We are going to send the digital data by the help of 1 or 2 Mbps to the modulator, and then we are going to generating the analog signal. Before generating the analog signal, it will be check the frequency synthesizer and then zero RAM sequence. So we are having a 11 chip Barger sequence, and then it will be sent through the modulator, and the generator will be generate the analog signal. And we are using a infrared, so it will be sent to the digital data and it will be converted to the encoder by the help of 4 to 16, or we are using a modulator in the form of pulse post modulation, and then it will be generated the analog signal. And now we are going for a Bluetooth. So always Bluetooth is a wireless LAN technology only. Is full and full designed for to connect the device by the help of wireless. So we have seen already wired wired network, that is topology we are using here. So we are going for a Bluetooth. It is a low cost and then low power. It is the shortest range of wireless communication technology used in networking. Mobile phones and other portable devices we are using in a Bluetooth. Bluetooth wireless technology also enables devices to communicate with each other as soon as they come within the range. No need to connect or plug in into install or enable to configure anything. Although the range of each Bluetooth device is approximately 10 meters, but the distance can be increased to 100 meters with optional amplifier placed at strategic locations within a building. Bluetooth does not need to be set up, it always on. The device to communicate do not even require line of sight communication. So different devices can be automatically linked up with each other as soon as they come into the range. That is, it creates a temporary network or a personal area network. The Bluetooth specification is an open global specification defining the complete system up to application level. The Bluetooth promoters group has made Bluetooth is an open specification rather than keeping it restricted and proprietary, because more customers can adopt it as many manufacturers are producing it. So I explain once again, the Bluetooth promoters group of it can be made by the Bluetooth as a open specification. Why means it then keeping it restricted and proprietary, because more consumers can adopt it as many manufacturers are producing it. So in Bluetooth technology, it uses the globally available unlicensed ISM radio band of 2.4 gigahertz. So the ISM means industrial, scientific and medical terms band frequency. It can be used for 2.4 to 2.484 gigahertz. Do not require an operator's license from any authority. Bluetooth support both voice and data, as it supports both circuit switching and packet switching. So we are going for a architecture. So in this architecture, we are going to see a single slave piconet and then multi-slave piconet. One master and then one slave is called as a single slave piconet, and then multi-slave piconet means there is a three slaves and one master. So the basic element of Bluetooth is piconet. Piconet is a collection of slave devices operating together with one common master. So it shows the both single and multi-slave. See here, this is a multi-slave, and then it is called as a scatter-net. So several piconets can be established and linked together in a topology is called as a scatter-net. In scatter-net, some devices are common to more than one piconet. So only one piconet can be active at a time. Different piconets in a scatter-net can participate through time division multiplexing, that is TDM, sharing a common channel. So in this we are going to see what is mean by L2 cap layer also. So L2 cap which is placed in a Bluetooth layer. So it is a radio layer. So in this radio layer, we are going to include that L2 cap and baseband layer. Radio layer is roughly equivalent to the physical layer of the internet model. Bluetooth devices are lower power and have a range of 10 meter. So it uses the 2.4 gigahertz ISM band divided into 79 channels of 1 megahertz each. So in FHSS, Bluetooth uses frequency hopping spectrum method in the physical layer to avoid interference from other devices or other networks. Bluetooth hops 1600 times per second. A device uses a frequency for only 625 microseconds before it hops to another frequency. And then for modulation, to transfer bits over a signal, Bluetooth uses a specified version, that is FSK and then GFSK. So GFSK means as a carrier frequency. Now we are going to see a baseband layer. So in baseband layer, we are having a single secondary communication and multi-secondary communication. So this layer is equal to max sub layer in LAN. The access method is TDMA. The primary master and secondary slave communicate with each other using a time slot. The length of the time slot is exactly same as a dwell time, that is 625 milliseconds we are going to use here. And then TDMA, Bluetooth uses a form of TDMA that is called time division duplex. That is TDMA is a off duplex communication. In single secondary communication, if the piconet has only one secondary, the TDMA operation is very simple. The time divided into slots of 625 microseconds. So the primary uses unnumbered slot and secondary uses odd number of slot TDD and TDMA is of duplex. So in slot 0, the primary sends, the secondary receives, and in slot 1 the secondary send and the primary receives. And then we are going for a multiple secondary communication. The number of secondary slave is more than one. The primary is master uses even numbered slot and secondary uses odd numbered slot. All secondary listens on even number slot, but only one secondary sends in an odd number slot. It shows the multiple secondary communication. In slot 0, the master sends a frame to slave 1. In slot 1, only slave 1 sends a frame to the primary because the previous frame was addressed to the secondary one, otherwise slaves are silent. So in slot 2, the master sends a frame to slave 2. In slot 3, only slave 2 sends a frame to the primary because the previous frame was addressed to slave 2. Other slaves are silent here. And then we are going for a frame format. Before we are going for a frame format, we have to know the physical link. There is a two physical link. One is SCO and second one is ACL. First one synchronous connection oriented. It is used when avoiding latency is more important than integrity. So SCO is used for real-time audio where avoiding delay is all important. We are going for a synchronous connection link. It is used when in data integrity is more important than avoiding latency. So we are going for a frame format. The frame is a baseband layer, can be one of three types: one slot, three slot, and then five slot. For one slot frame exchange, 259 microseconds is needed for hopping and control mechanism. This means that a one slot frame can list only 625 to 259 or the 366 microseconds. Three slot frame occupies three slots. However, 259 microsecond is used for hopping. The length of the frame is 3 into 625 minus 259 is equal to 1616 microsecond or 166 bits. A device that uses a three slot frame remains at the same hop for three slot. That is, it uses same carrier frequency. Even though only one hop number is used, three hop number are consumed. That means the hop number for each frame is equal to the first slot of the frame. So the header contains address, type, flow, acknowledgement, sequence, and then checksum. Address field is identifies which the 8 active devices the frame is intended for. If the address is 0, it is used for broadcast communication from primary to secondary. And then type is used for it fields identifies the type frame type ACL or SCO, that is polar null, or flow is used for F is used for subfield is 1 bit for flow control. When it is set to 1, then it is asserted by a slave when its buffer is full and cannot receive any more data. And then A for acknowledgement, the 1 bit acknowledgement subfield is used to piggybacking an acknowledgement into a frame. Bluetooth uses stop and wait ARQ. 1 bit is sufficient for acknowledgement. And then we are going for a sequence. The 1 bit subfield is used to number the frames to detect retransmission. The control is stop and wait, so 1 bit is enough. So we are going for a checksum. The 8-bit error correction subfield is checksum to detect errors in each 18-bit header section. The 18-bit header is repeated 3 times for the total of 54 bits header. On the receiving side, a simple circuit examines all 3 copies of each bit. So if all the 3 are the same, the bit is accepted. If not, the majority opinion wins. So 58 bit of transmission capacity are used to send 10 bits of header. The reason is that to reliably send data in a noise environment using cheap and low powered devices with a little computing capacity. So a great deal of redundancy is needed here.